Thank you. Hi, guys. Today we'll do a real quick overview of what's available to the VCPP market in containers. I'm happy to, answer your questions and cater, or, make this discussion go the way you guys want it. So feel free to ask questions at any point in time. If you already know the material, let me know, and I'll just skip through it, and we can just take more questions. Who's participating in VCPP today? Are you providers in the VCPP market? 1, 2, 3. Okay. And the rest of the guys just here to learn about containers, I take it. All right, good. All right. So just a quick overview of what we are doing in the VCPP market is we are pulling together a cloud platform solution that enables partners to offer virtual machine and container services, amongst other services, both in the private cloud and in the public cloud space. But this particular talk is focused in on what can you guys do in the container space, what services can you offer depending upon where you are at in your journey in the cloud. So when it comes to containers, there's different uses of containers. So one can start, if you're pretty early in the container as a developer in the container journey, you start with individual container instances with Docker, and then you migrate to a container service, which essentially is orchestrating your application, which now consists of more than one container. And then you can also choose to use an application service, which is a PaaS service. And in the future, function services come about. Now, this talk is squarely focused in on the container service, which is you've decided as a developer, your customers have decided to orchestrate their containers, and the orchestration that we are going to talk about today is Kubernetes. So that's the market that we're talking about over here. And we'll talk about the solutions that you as a provider can offer to your customers in providing containerized orchestrators to your customer, mainly Kubernetes as a service. So that's the focus. So I just want to flash this slide indicating two things. One is that containers are growing, they're growing rapidly, which is why you probably are here. And two is that a lot of containers are running in virtual machines deployed in the cloud. So it's that, pattern that we are seeing, and that's what also Pat mentioned in the keynote, saying that containers are running in VMs today. This is what we're seeing today. However, when you talk about orchestrated solutions such as Kubernetes, it's pretty complicated. There's lots of players, lots of tooling in the market, and Kubernetes is not just one layer, but you got to have infrastructure, orchestrators, container repositories. And how do you multi-tenant it if you're a multi-tenant provider, et cetera. So how do you monitor it? How do you distribute your image repositories across multiple clouds, et cetera. So there's more to it than just installing Kubernetes and going with it. It's a little complex, which is why we need to come up with some solutions that tame that complexity, but still enable you as a provider to offer services. So from the developer perspective, we started out with, they can leverage Docker and have single containers running applications. So typically the use case for this is you take a monolithic application and you want to modernize it using the Docker image library, and you'd use this path. And Vic today offers that capability where you can, via Vic, deploy containers using containerized images. And so you have container runtime. But we're not talking about this. We're talking about Kubernetes, which allows you to take an application and have it orchestrated in a 12-factor or microservices format where you have multiple containers manifesting that application or bringing that application, and Kubernetes is the orchestrator keeping that application up. So in the mode that your developers have matured into writing Kubernetes orchestrated applications. We have a few solutions for the VCPP partners, and it depends upon where you are in your adoption of technology, and depends upon where you are in your service offerings to your customers. You could have, so that's the legend over there. So this is, the light blue is where you build and operate your infrastructure. So it's more asset heavy. So you have data centers, you manage the hardware, operating system, network cooling, everything. And you also then could use some software to enable Kubernetes. Or in the dark blue, you're a asset light partner where you can leverage VKE, which is another solution, and offer Kubernetes services to your customers. Or you could do both. You could, and a lot of cloud provider partners in VCPP are doing both asset heavy and asset light, where they might use PKS for the asset heavy infrastructure to offer container workloads to the customers, but also use VKE to enable Kubernetes on AWS today. And we can go into a little bit of detail. Any questions so far on this slide? Any concerns, comments? Okay, let's keep going. All right. So from the VMware portfolio perspective, just to present a different perspective on that slide, the Cloud Native Apps portfolio consists of a bunch of products and services. As I mentioned, these products and services you build, operate, and consume as a provider, whereas over here your tenants consume these and you manage them on top of public clouds. If you're running public cloud, you might choose to go down the asset light way, or for those public cloud providers who are using VCD, we have a solution called Container Services Extension, which is an extension to VCD that allows you to offer your tenants, the ability to create Kubernetes clusters. Now, if you're a private cloud provider, dedicated cloud provider using vSphere, you can use PKS to offer a similar service where in both the CSE and PKS services, your customers, your tenants would come in and self-service the creation of a Kubernetes cluster. All right. So next, what I'll do is I'll show a little demo of what I mean by self-servicing a Kubernetes cluster, and I'll show it in the context of VCD. Let me just run that demo over here. All right. So in the context of the infrastructure stack, you've got a vSphere over here. You've got physical infrastructure, vSphere. You've got NSX, and you've got vCloud Director over here, providing a multi-tenant cloud provider offering to your customers. What you do then is install CSC as an extension to VCD, and CSC extends VCD, allowing your customers to consume infrastructure as containers. So essentially what that would be is your customers could come in and say, I would like a Kubernetes cluster, and a Kubernetes cluster will be created. And one tenant would create the cluster in their own virtual data center, completely isolated from others. So you can have multiple clusters in one VDC, and obviously you can have multiple clusters in multiple VDCs belonging to different tenants. So so this is the CSC model. So essentially what we have is the vCloud Director installation. We have the operator over here who's set up VCD. He's also set up CSC, the Container Service Extension, which is essentially an OVA that you upload to vSphere and register it with VCD. And once you do that, you get the CSC control plane, which allows the tenants to create clusters And once the cluster is created, you'll get an application that will contain the master etcd nodes that would then provide the Kubernetes API. And this would be the standard Kubernetes API that kubectl can work against and the Kubernetes dashboard can work against. And this is fully multi-tenanted because of the VCD constructs. And so a second Kubernetes cluster can be created by another tenant using the same underlying infrastructure. So that's the mode of consuming both virtual machines and containers now. And these containers will run alongside virtual machines in the same virtual data center that VCD manages. So going further through the demo, what we have over here, and by the way, Jorg is sitting in the back, the guy who authored this demo. We have two screens to VCD. This is, the screen on the left is essentially that's the control screen, basically a different section of the UI. And the screen to the right is the screen that shows the workspace of the tenant. Both of these are tenant perspectives. So the tenant logs in and goes to the hamburger menu over there on VCD, clicks on the libraries section, gets into the service library. Over here, essentially what they see are 4 tiles that allow them to create clusters, delete clusters, scale out, scale back clusters. And this is on a per tenant basis. So one tenant creates clusters in their own organization, VDC. And so over here, what this tenant is doing is they're executing a workflow that essentially, nothing's changed over here. With a one-click finish, they can get to a Kubernetes cluster. So remember I talked about the complexity of building cluster, infrastructure and harbor and all those things. Over here we're trying to simplify the consumption of these container infrastructure pieces, i.e. the Kubernetes cluster. So once you go about executing that workflow, now you'll see that over here in your workspace where you've got a VApp that is running some virtual machines and some workloads in virtual machines. You see this other VApp show up that's essentially a collection of virtual machines, but it is really a Kubernetes cluster because these virtual machines are the masters and the nodes and the etcds. And so once that comes up, So this, while it's coming up, we also want to show you that was a simple, mode of creating a cluster. But if you turn on that switch, you can toggle into the more complex settings, which essentially allow you to direct or place the cluster in a particular VDC, connect to a particular storage, use a particular network, change the number of nodes, etc. So you can configure to a certain extent the qualities of this Kubernetes cluster, where it connects to, what CPU utilizes, etc. And what networks you can choose. You can also determine the version of the Kubernetes you want to run. So that's templatized in the VCD, on the VCD side by the administrator. So the tenant can declare support for 1.9 or 1.8 or whenever GKE comes out with their next version, the administrator goes in and creates a new template with that version of Kubernetes and creates another template which will manifest as another option in this drop-down. And so that's going on over here, and then you could choose to configure and customize that container cluster in such a way. Now what we're showing you is that this cluster is still operating its, it's creating its nodes over here, and once it's created, we'll show you what's running inside of it. So now it's done over there, and that cluster is ready for consumption. All the VMs are powered on, and remember these VMs were the nodes of the cluster and the master. And over here, so once the VApp is ready, which contains the cluster, we also have a description that tells you how to connect to that cluster. And this is essentially, if you take that text and plug it into a CLI, which we'll do now, you'll be able to connect to the cluster. This is using kubectl. The very standard stuff. The Kubernetes is plain vanilla Kubernetes, so we don't change that. So any application that requires specific features of Kubernetes will be able to leverage those. And over here, we are showing that we can connect to the Kubernetes, and we are getting the nodes of that cluster. And we can see that there are 4 nodes over there, as there are 4 nodes here. Just showing you that it is indeed a Kubernetes cluster. And so over here, what we're doing is we're creating an application in that cluster, a containerized application, the traditional sock shop application, if you guys have ever used, kick the tires in Kubernetes. So here we're actually spinning up some containerized apps in this Kubernetes cluster, which essentially is a collection of VMs, and the VM utilization will therefore go up because it's doing things. Any questions so far? So over here, this is a demonstration where what we want to do is we realize that this cluster is too small and we want to scale it up. So how do we do that? We go to the tile section again and execute the expand cluster workflow, and that will result in adding a couple of nodes, worker nodes to that cluster. And again, this is, you can choose the version of Kubernetes you want. You can specify which network those clusters connect to, etc. So now we've got 2 additional nodes in this cluster. And we can show you that, via the kubectl command that indeed we have 2 more nodes over here. So that's that. And it's still powering up, maybe not ready. Oops. Okay. So now what we want to do is, so what we've described so far is, as a tenant, you've gone to the VCD UI, you've clicked a button, you've gotten a Kubernetes cluster, and you can take it to market and start writing containerized applications against that cluster. Pretty simple to do. You get the underlying multi-tenancy. Your resources are constrained to only use that VDC. And the container services extension is available at no additional cost. You can link it to your existing vCloud Director instance and start consuming infrastructure that way. But you might want to also monitor that infrastructure. So you know that with Wavefront or Prometheus, you can connect to the Kubernetes cluster and figure out what's going on in the cluster. So to set up Kubernetes against this version of Kubernetes or even the PKS version is pretty simple. You go to the Kubernetes website and set up your Wavefront proxies, which is essentially running a couple of apps inside of the cluster. And once you do that, that's basically just copying some information over there and pasting it there. Once you do that, you can have Wavefront monitor the workload of that cluster, and you can see graphically the workload on that cluster. What you do is over here, the only thing you'd want to change is change the name of the proxy so that you can identify it in the Wavefront UI. So it's basically just like a label to your cluster, and every cluster would have a unique label so you can uniquely identify its utilization. And over here, essentially, we're using Heapster to collect information from the cluster, and that integration would allow Wavefront to receive the data. And once you do that, you go back to the Kubernetes dashboard, and you filter your cluster's label to identify. So this is all the cluster information, so coming from different clusters. But if you filter it by your label, then you get your particular cluster's utilization. So right now, there's nothing much going on. We created the cluster, and it's doing nothing. And what we're going to do again is on this cluster, we're going to start the sock shop application.
Ladies and gentlemen, VM Village is now closed. Please make your way
We'll still
to
keep
the
going.
nearest exit. Thank you.
Okay, so we're starting the sock shop application over there, and you'll see a slight bump in the utilization. Again, showing that.
Ladies and gentlemen, VM Village is now closed. Please make your way to the nearest exit.
That as a provider, you want to actually add some value to, your customer, and maybe have some way of monetizing that service offering, which would be container clusters. So what we've done is we've dove deep into the way you can expose via multi-tenant way Kubernetes to your customers. You can do something similar with PKS, and CSC is first initial implementation of our Kubernetes journey. It's pretty rudimentary right now, but we're continually going to add to it. Over time, what we'll do is we'll leverage all the PKS value such that CSC will get the day two ops benefits. We'll have network integration with the network plugin, so that when a namespace in the Kubernetes cluster is created, we automatically create a logical network, connect firewalls, load balancers, ingress controllers, and all that to it. And with CSC, we've currently got Weave networking going, but with PKS, you'll have VXLAN as your overlay network. Over here, the underlay is still a VXLAN, and the benefit is you don't have to change your existing infrastructure. You go with what you have right now, which is NSXV. But PKS will allow you to get to NSXT as well and leverage those benefits. And so let me just stop over here to see if you have any questions. So this is what we talked about is all, asset heavy, on-prem, your vSpheres, your VCD, offering dedicated private cloud or public cloud services. The other option that you have if you're an asset light partner is to leverage VKE, which again will integrate with Harbor, and you get the benefits of Harbor, which is an enterprise grade container repository. You'd be able to prevent malicious images from being run, and you'd also be able to hook up multiple harbors and exchange container images. You'd be able to, with VKE, scale out or in your cluster based on demand automatically. So you get some utilization benefits and therefore cost benefits with VKE. VKE currently runs on AWS, will eventually run on Azure as well. So you can have your container offering be offered to your customers who got .NET backends or Lambda backends or both in one consistent workload management plane. That plane will also give you the capability of containing the size of container clusters, just to limit the amount of cost of that to the tenant. And also you can have sophisticated RBAC indicating, group access. So group one can talk to cluster one, but no other cluster, and so on and so forth. So those are the values of VKE when they come out. And across all these possibilities of offering container clusters, both on-prem, asset heavy, and in the cloud, asset light, is that the Kubernetes version, 1.9, could be consistent across the multi-clouds, such that your applications, your developers, your tenants' developers' applications.
Ladies and gentlemen, VM Village is now closed. Please make your way to the nearest exit so that we can reset the room for tomorrow morning. Thank you.
Can run either in the cloud, on-prem, and share images. So I mean, it's the story is just starting, and I think we're going to add more and more to it. So just stay tuned.
What's the reason for containers to run inside VMs? Is there a particular reason?
Well, you get the benefit of network virtualization with VMs, so SDN on the VM. If it's running in bare metal, you don't get that. That's one obvious advantage. Yeah. Yep. Okay. Yep.
There will be a network driver for CSE, but when, so that
So we'll leverage PKS for that, and so today we are using Weave networking, so we don't need the network plugin. But when we transition to leverage PKS to do the heavy lifting, the creation of the container cluster, and also intercepting the namespace requests, we'll leverage PKS's integration for of the network driver. And that will happen over the course of a year or about 12 to 18 months. So you'll be able to see that demo that I showed you with the same exact interfaces, or maybe even more sophisticated interfaces, but with a much stronger underlying system with PKS supporting us. Does it sound interesting? A show of hands. Okay. For the guys who aren't providers, what was interesting? Okay, for the guys who are providers, which one was interesting? So we talked about CSE, PKS, VKE.
I like the CSE integration.
Yeah, okay. With the UI and all that? Yeah, all right.
You don't get high availability of the master, I think. You only get one master.
Only one master today, yes. It's
Just for starting, it's okay,
Yeah.
but if you want to deliver
exactly, yeah.
production grade product, then
Just wait for a few months and we'll work on that too, yeah, with multi-master and PKS. How about you in the back? Which CSE? Yeah. Okay. All right. Thanks a lot, guys.